Hello students, now I will take the question number 26 to 30 in NEET 2016. Question number 26 to 30. Question number 26. 26 is the intensity at the maximum. Intensity at the maximum in Young's double slit experiment. Young's double slit experiment is I naught. Is I naught. Distance between two slits is d equal to 5 lambda, where lambda is wavelength of light used in experiment. What will be the intensity? What will be the intensity in front of one of the slits on the screen, placed at distance d equal to 10d. So this now options are: first is I naught upon 2, second I naught, only I naught, and third is I naught upon 4, and fourth is 3 I naught upon 4. Now the solution. You are given the Young's double slit experiment in which the maximum intensity is I naught, and you have to find the intensity in front of one of the slits on the screen, which is placed at the given distance. So here d equal to 5 lambda, and this capital D is equal to 10d. So now put the value of this 5 lambda here, then this will be your 50 lambda. This is so much. Intensity I equal to I naught cos square 5 upon 2. This is the formula to be used. Phi is the phase difference between the waves. phase difference. Phi equal to 2 pi upon lambda into delta x. Delta x, this is the path difference. Delta x, path difference. So we have to find the path difference delta x. So path difference delta x, this is equal to y into theta, as we know. Sorry, this is d into theta, and this d theta is equal to y upon d. So this will what here? These are the slits S1 and S2. This is the screen. These are the points. This you are given D. This is point P1, this is point P2. The P1 in front of this S1 and P2 in front of S2. So now we have this origin O, this is the middle point. Suppose O dash, then this distance is d by 2. So much is d by 2. So what will be there? That this is given to your y. Then theta is what? That if you say to this one, then this is not from here. So this distance is to be by, then path difference between these waves, and this is so much. If we drop the perpendicular, then this angle is theta. So if you drop the perpendicular from this one, then this angle will also come out to be theta. So what we have? There's this tan theta from here. So this is your d into y. Y is equal to d upon 2. This d upon 2. This is now your d upon 2 into d. So now we put the value. This is given to us. So delta x. Delta x equal to d. D is given to 5 lambda. And this is again your 5 lambda. This is given your 50 lambda. So this 25, this is now your 2, this lambda will cancel. So this is your lambda upon 2. This is lambda upon 2. Five lambda, this 2 also here. So this is lambda upon 4. Therefore, phi is equal to 2 pi upon lambda into lambda by 4. So this will cancel. This will cancel by 2. So this is pi by 2. This is now phi. Therefore, intensity I equal to I naught cos square. Now phi, this is your pi upon 2 upon 2. So this is I naught cos square pi upon 4. So this is I naught 1 upon root 2 whole square. So this is I naught upon 2. So at this point, this P1 or we take this P2, the distance, the intensity will be half of the maximum intensity. So our option, right option is to first. So what is given that First you have to find this formula, you have to use this formula, and then find the phase difference, and then path difference. While calculating the path difference, this you remember that this by that we get here, this should be d by 2, because this point is just half of this distance. This is so much. So this is now d by 2. So much is given to be d by 2. This is d by 2. So in place of y, we write down d upon 2 and then put the value, then find the phi and the intensity. And also remember, if suppose this question is given in either way, what is the value of d, what is the value of capital D? When the slits are of same width, the slits are of same width, then always remember that the intensity in front of each of the slits will be half of the maximum intensity. So whether you calculate or not, you can directly say it that the intensity in front of the slits is I0 upon 2. तो स्लिट की आपको डी का मान दिया हो, स्मॉल डी का मान दिया हो, और इसमें आप कैलकुलेट करके निकालें तो कैलकुलेशन से भी यही आएगा। और वैसे भी थ्योरेटिकली ये क्लियर है कि अगर दोनों स्लिट्स की विड्थ इक्वल है तो उनके जस्ट सामने वाले पॉइंट पर इंटेंसिटी का मान अधिकतम इंटेंसिटी का आधा होगा। So this is the question number 26. And now go to question number 27. Two non-mixing liquids. Non-mixing liquids of density rho and rho n greater than 1 are put in container. Are put in container. The height of each liquid is h. Height of each liquid is h. A solid cylinder of length L, solid cylinder of length L is put in this container, is put in this container. The cylinder floats with its axis. The cylinder floats with its axis vertical and length PL P less than 1 in denser liquid. Denser liquid. The density D is equal. The density D cylinder of length L is put in the container L and density D. Density D is put in container. So the density D is equal to now the options. First option is 1 plus n minus 1 p into rho. Second option is 1 plus n plus 1 p into rho. Third option is 2 plus n plus 1 rho. And fourth option is 2 plus n minus 1 p into rho. And now this the solution. You are given the two liquids which are not mixing and they are kept in a container. The one liquid has the density rho and second the n rho. N is greater than 1, it means this is second liquid is of higher density and the height is given to be h in liquids, each liquid, and the length of the cylinder is L, density is given to be D. So what we have that suppose this is the container. This is the container. This is the liquid. Now this liquid is given of density and rho. Here we have this another liquid and we have this cylinder. This is another liquid. One more liquid we have here. Its height is h and its height is also equal to h. Height of each liquid is h and the density of this liquid is density is equal to rho. The length of this cylinder, this is an axis. The length of this cylinder is to be L. This is complete length is L. This is L. And this is given the cylinder floats with its axis vertical and length PL in the denser liquid. It means that this distance, here we have, this length is given to you, this PL. This is PL. This is so much. Then definitely this distance will be your L minus PL. This is so much. L minus PL. This is from here. So what we have? This cylinder will float when the weight of the cylinder is equal to weight of the liquid displaced. So for floating, weight of cylinder equal to weight of liquids displaced. So we consider that this W equal to W dash. So what should be? That this W is equal to, you are given the length, so this is your mg equal to m dash into g. G the gravitational acceleration, this will cancel. So with this m, this is now density. Density of this solid cylinder is given to you d. So now d into a into the length is given to you L. This is now volume and density. Now this is into G equal to m dash, the mass of both the liquids. So in the first liquid, this is now density is m rho. So here this A, this density, this is n rho. This is now given here, and this should be multiplied by A into L. L is given PL. This is now PL. And this plus this rho into A into, now length is this L minus PL. So here is L minus PL. This is now volume and density. So this is now mass, and then this whole is multiplied by G. So this G will cancel from both sides. So what we have, this D A L equal to, now this A and L, that will be common. So this is your N rho A P L minus this plus rho A L into 1 minus P, and this so much, and this A into L, that is A into L, this will cancel from both sides. So D equal to, this is your N rho plus N rho P, and this is now plus rho into 1 minus P. This is now left. So what we are having this? This is N rho P plus, this is now rho minus rho into P. So this is rho into P, you take common from here, and rho is also common from all. So we are getting what this 1 plus, this is now your P minus 1. This is N minus 1 into P. This is so much. The rho and P you take common, so this is now N minus 1. This rho we have taken common, so this is now 1. So now density is equal to rho into 1 plus n minus 1 into P. So this is what the given answer to this 1 plus, this is now first one. So our answer is first. So what we have to find here, that you have to use the principle of floating that was given by Archimedes, that the bodies float in the liquids when the weight of the body is equal to the weight of the liquid displaced by the body. So here you were given the two liquids, so you have to find the mass of the two liquids which are displaced by the cylinder, and then you sum up and calculate that what will be the density of the cylinder. तो ये बहुत कॉमन सा क्वेश्चन है जो कि आर्किमिडीज के प्रिंसिपल पर आधारित है ना, और आपको इसमें यही निकालना है कि भाई जो सिलेंडर है उसका वेट कितना होगा और जो लिक्विड डिस्प्लेस उसके द्वारा किया गया है उसका वेट कितना होगा, और फिर आप इसको कैलकुलेट करके और डी का मान निकाल सकते हैं। तो यद्यपि ये आपके 12th क्लास के कोर्स में नहीं है, लेकिन क्योंकि आपने आर्किमिडीज प्रिंसिपल पढ़ा हुआ है इसलिए ये क्वेश्चन यहाँ पर दिया गया है आपको। Now question number 28. Question number 28. Consider the junction diode. Junction diode as ideal. As ideal. The value of current flowing through AB is now options. Now here we are given in the figure that this is now wire AB, this is a wire of 1 kilo ohm. 1 kilo ohm. This is given you plus 4 volt and here is minus 6 volt. So this is your A and this is your B. Now your first option is given here, that is 10 raised to the power minus 3 ampere. Second is 0 ampere. Third is 10 raised to the power minus 2 ampere. And fourth is 10 raised to the power minus 1 ampere. These are the options. Now first you have to understand that here we are given as ideal diode. What is ideal diode? In ideal diode, the resistance in the forward wise is 0 and the resistance in reverse wise is infinity. This is called the ideal diode. Here we are given the diode in the forward wise. It means the resistance of diode is 0. So only resistance we have to take, this is now 1 kilo ohm. And the potential difference is given to you, instead of 4 volt, this is now your minus 6 volt. So this will be your 10 volt. So potential difference. Delta V equal to 4 minus 6. So this is your 10 volt. And now I equal to delta V upon R. Delta V, this is now 10 and this is now 1 kilo. 10 raised to the power 3. This is given a kilo ohm. So this will be your 10 raised to the power minus 2 ampere. So our right option is minus 2. This is now third one. This is now third option. So what happens that when these ideal conditions are given, then many of the students are confused that what we take the resistance of this diode. So always remember that if the diode is ideal, then resistance in forward bias is 0 and in that of reverse bias it is infinity. So this is question number 28 and now question number 29. A car is negotiating. A car is negotiating a current, a curved road of radius R. The road is banked. At an angle theta. At an angle theta. The coefficient of friction between the tire of the car and road is mu s. The maximum safe velocity on this road is, now the options. First option is square root G into mu s plus tan theta upon R into 1 minus mu s tan theta. Now second option, square root GR into mu s plus tan theta upon 1 minus mu s tan theta. So now third option. Third option is This is now your GR square. GR square. GR into mu s plus tan theta upon 1 minus mu s tan theta. And now fourth is G upon R is square root G upon R mu s plus tan theta Gs upon R square. This is now R square. Gs upon R into mu s plus tan theta upon 1 minus mu s tan theta. These are the options. This is the use of the shape velocity. This is the direct answer given here. We know the speed when the body moves on a banking road, and that now here shape velocity on banking road V equal to square root of GR into mu s plus tan theta upon 1 minus mu s. This is a direct formula. So we have to use the formula directly. So you can see that our right option is third one. So our answer is third. This is the correct answer. Now question number 30. A long straight wire of radius A carries a steady current I. The current is uniformly distributed. Current is uniformly distributed over its cross section. The ratio of magnetic field B and B dash at a radial distance A by 2 and 2A respectively. respectively from the axis of y is. Now first option is 4, second is 1 by 4, and third is 1 by 2, and fourth is your 1. Now the solution to this question. If you read this question carefully, then this is the application of Ampere's law. When the current passes through a solid cylinder of radius r. So the only confusing point here is that the radial distance a by 2 and 2a. When we find the magnetic field, because of the cylinder carrying the current, then the points which are given perpendicular to the axis of the cylinder, they are always the radial points. So this we have to keep in mind, that radial points are those that we have studied in the classroom. Suppose this is the given cylinder. This is so much. This is now axis of the cylinder. It carries current I. So current is distributed uniformly. This is not so much. This radius is given to A. These are the points, so much, and this point is A by 2. This is now suppose P1, and this is point your P2. This is now your 2A. This is so much. So this point is inside the cylinder and this point is outside the cylinder. Because these points are along the radius of this cylinder, so they are called the radial points. So do not get to be confused that when we are given the radial points in any of the regular body like your sphere, cylinder or your cone, then radial points are always those points which are along the radius of the given body. So here this B inside and this is now B outside. So B inside at point P1. This is now your B inside is equal to mu naught I upon pi r square into r. This is the formula. Here you have to use here r equal to a and this r equal to a by 2. This is so much. So what we have? B in equal to mu naught I upon pi a square into a by 2. A and a will cancel. So mu naught I upon 2 pi a. This is inside the cylinder. And now outside to this one at point P2. At point P2, B out equal to, this is your mu naught I upon 2 pi a. This is a direct formula. And here r equal to 2a. So this is mu naught I this will be 2 also. This is now 4. So this is mu naught upon 2 pi, r is given to you 2a. So this will be your mu naught I upon 4 pi a. Mu naught I upon 4 pi a, mu naught I upon 4 pi a. Both are equal. Both are equal. So this is you are given to be now b dash, b in or b. This is now your b. This is the b out or b dash. So this is now your b dash. So now b upon b dash equal to 1:1. Both are equal. So the ratio of these at these radial points, the magnetic fields will be 1:1. So our right option to this one is 1. This is now your fourth answer. So this is what your question number 30. So today I have told you the question number 26 to 30. So these are the 5 questions, and the remaining 15 that I will do on the remaining on the each day 5 questions. So this will help you to understand the questions. Thank you.